Okay, so today we're going to go over 1.5, and the whole point of it is to represent a story context using tables, graphs, and equations. Use function notation to write explicit and recursive rules. Remember, I told you you're going to get better and better at this. So number one is, how can I find the pattern growth in a story context? And number two, how does that pattern of growth appear in each of the representations? Now we saw, I think you are used to when it looks like a linear pattern, because we have that star of the show, also known as the slope or the rate of change or constant difference. So now we're going to get used to looking at other ones. Okay. So here's the context of this big problem that we're going to solve right now. It says, maybe you've received an email like this before. Hi, my name is Bill Waits, founder of Super Scooper Ice Cream. I'm offering you a gift certificate for our signature Super Sundae, an $11.95 value. If you forward this letter to 10 people, when you have finished sending this letter to 10 people, a screen will come up. It will be your Super Sundae gift certificate. Print that screen out and bring it to your local Super Scooper ice cream store. The server will bring you the most wonderful ice cream creation in the world, a Super Sundae with 3 yummy ice cream flavors and 3 toppings. This is a sales promotion to get our name out to young people around the country. We believe this project can be a success, but only with your help. Thank you for your support. Sincerely, Bill Waits, the founder of Super Scooper Ice Cream. That's hard to say 5 times. Okay, so these chain emails reply on each person who receives the email forward. I know, me too. Email to forward it on. Have you ever wondered how many people might receive the email if the chain remains unbroken? Okay, to figure this out, assume that it takes a day for an email to be opened, forwarded, and then received by the next person. So on day 1, Bill Waits starts by sending an email out to his 8 closest friends. They each forward it to 10 people, so that on day 2, it is received by 80 people. The chain continues unbroken. How many people received the email on day 7? Okay, so the very first thing that I want to do is I want to make a table, because it's kind of making sense, but it's not like clear in my brain. Okay, so I'm going to make a table. And the table is going to kind of look like this. And they're going by days, right? So on the X side, it's going to be days. And on the right side, it's going to be number of emails out. Okay. So is that the term that they're using? Hold on a second. Received by 80 people. So we'll use the term received by number of people. Okay, does that make sense? Okay, so what I want you to do is, oops, I lost that. What I want you to do is I want you to come up with how many people, like on day 1, what is that? On day 2, what is that? So go ahead and pause really quick and come up with at least 3 lines of this table. 1. Okay, so the very first day, it says here, on day 1, he sends it to 8 people. Okay. On day 2, right? On day 2, it's already at 80 people. Right? Uh-oh, it's catching up, I promise. Okay, it's gonna come up, I promise. Okay, and then day 3, what would I do then? How would I get the next row of people? There it goes. Yes, very good. Thank you. Thank you. Both of you are right. Good job. Okay. So this person said, I'm not even going to tell you how many, the person who wrote it in here, they didn't even tell me the number. They told me how to get it. Now, how to get it is much more powerful than the actual number. So I'm going to write, Ms. Johnson, all I'm doing is I'm multiplying by 10. So that means I'm going to multiply by 10. Oh, so notice here, the way you wrote it the three of you who wrote me back, you're already telling me in terms of the recursive formula, right? So let me write my recursive formula off to the side here. So here's my recursive formula. So that's going to be next is equal to previous times 10. So boom. So for those of you who said, Miss Johnson, I don't understand how to do recursive, you just did it, right? And then the other part of it is you just have to say starting at day 1 is 8 people. Okay. So for those of you who said, Ms. Johnson, I don't understand how to do recursive, you just did it. Exactly. Yes, ma'am. Okay. So someone else said in the chat, Ms. Johnson, this is geometric. Exactly. So the thing that you should say, like, wait, how did that person know it was geometric? Right here, this told you. It's like, I don't know, maybe you write like this. This is the little bubble. I'm geometric because I'm getting multiplied by 10, right? So that's what this thing is saying. Like this function is telling you I'm geometric because I'm getting multiplied by 10, right? So the multiply by 10 should be boom. That means it's geometric, okay? Okay, so the next number I think is going to be 800, and I don't even need to write that because someone in the chat told me, Miss Johnson, I already found the rule, kind of. You're right. So here's what I'm going to do. I'm going to erase this part because well, no, I'm not going to erase that part. I am going to rewrite this just like I did before. So instead of writing this as 80, I'm going to rewrite it as 8 and then times that 10, right? Right? And then instead of writing 800 here, I'm going to write it as 8 times 10 times 10. And some of you are already, oh my gosh, Ms. Johnson, I already know how to do this. I already know what the explicit formula is. Okay, good. Slow down just a second. So some of you are like, Ms. Johnson, I know the explicit formula because I already see the number that's staying the same. I see what's changing. If this would catch up to me, hold on. Can you please catch up? Okay, it'll catch up. And then you'll be able to do that. So while this catches up here, your recursive formula in Mathland, oh, there it goes. It's not going to do it now. Your recursive formula in Mathland is going to be, and I'm going to type it so it'll actually catch up to me faster, is going to look like this. Okay, so it's going to look like this. I'm going to make it bigger. F of n is equal to f of n minus 1, right, times 10. 10. Good. Let me put that bigger. And then let me highlight that. Okay, so that's number 1. But then I also need my starting point. So I say f of 1 is equal to 8. Okay. Perfect. Does that make sense? So there's your recursive. This is your recursive in words. And now I want to build the geometric. So whenever you're building geometric, all you're going to do is you want to start here, except for now, I want to rewrite these. I want to write one more line because the one more line is just going to solidify it for me. 4 is going to be whatever number that is, and it's going to be times 10, right? So that's going to be your 8, and then times 10 times 10 times 10. And now I want to write this thing in terms of their, I want to write them in terms of my exponents. Now, if you don't know where the exponents came from, it came from, man, I wish there was a better way to write 10 times 10 times 10, right? And over here, because you know it's geometric, you automatically know it's going to have an exponent, right? So what do you see here that is staying the same every single time? What do you see is the same? Very good. The 8 and the 10, exactly. So over here in my rule, I'm going to write this rule here. I'm going to put my 8 here. I'm going to put my 10 here. And then earlier we talked to like Ricky, and Ricky found out, okay, I know exactly where that exponent is. So first I'm going to rewrite this using exponents. So can you right now pause and rewrite this so that it's condensed into exponents? Okay. So pause the video. Okay. So instead of writing 8 times 10 times 10 times 10, I'm going to rewrite it as 8 times 10 to the third. Same thing goes with the other one, 8 times 10 squared. And then the last one is 8 times 10 to the first. Now, I'm not filling this one out for a very specific reason. I'll explain in a second. But right now, what I want you to do is I want you to come up with where did we get this 3 from? And how is it related to 4? Same thing with 2 and 3 and 1 and 2. So Ricky told me the last time, someone else told me in the chat, that's right. But now, how are those two related? From 4 to 3, how would I get there? From 3 to 2, how would I get there? And from 2 to 1, how would I get there, right? So here, what should I put as this exponent up here in the chat? Exactly. It's my favorite code. Right here. What should we put right here? Exactly. Perfect. Anybody else want to check their answer? What exponent goes right here? Because this is the big deal, right? If you can get this number right in here correct, if you can get this number right here correct, then you're pretty good. So it's not a specific number. It's an expression. So here we did 4 and then we got 3. Very good. Very good. I got a couple people with this right answer. And I went from 3 and then I went to 2. So if you said n minus 1, then you're right. It is n minus 1. Well, why isn't it just n, Miss Johnson? Because it's not, right? Because look, this says 4 and this says 3. So if it was just n, then this would be a 4 here, but it's not. It went down by 1. That's what Ricky told us, right? So that's actually my explicit term. It's 8 times 10 to the n minus 1. Now look. Ms. Johnson, they didn't even ask you that. They just wanted how many people email on the 7th day. Well, okay, I could have multiplied by 2 over and over again, but now that I have this formula, I can actually plug it in. Okay, so then, and I'm going to tell you right now, you probably, I don't know if you did this already, you probably said, oh, I know how to do this. I can just multiply by 10 every single time and get your answer. Absolutely, absolutely. I'm just showing an alternative way. And most of the time, whenever I'm explaining to students what my alternative way is, I'm going to do it so that you can see there's more than one way to do the math. Okay, so my formula is 8 times 10 to the n minus 1, right? And in this case, we're looking for f of 7. So that means, Ms. Johnson, you want me to put a 7 right there? Yeah, I want you to put a 7 right there. So when I plug it in, I put a 7 right there. Yeah, put a 7 right there. Okay, so I'm just going to copy this exactly as I see it. I'm going to keep the 8. I'm going to keep the times 10 times 10. I'm going to change that n to a 7. And then I'm going to plug this into my handy dandy calculator because, again, it's my favorite. So it's right here. Okay, so, oh, this is pretty much the structure there. So I'm going to copy this because copy and paste is my favorite. Not that I can't type it in. So I'm going to go with 8 and I'm going to change this to a 10. And this one is going to be a 7. Notice that structure is exactly the same. The structure is the same. The numbers are different. So our answers are going to be different, right? So that's going to be 8 million. Okay, so this is going to be 8 million. Man, Ms. Johnson, 8 million. Oops, I don't know how to write million. 8 million people will receive this email. Yeah, the idea behind this, if you think about it, is like whenever a tweet goes viral, right? When a tweet goes viral, like you, the first person, sent it to all of your followers. Yes, absolutely. Thanks for asking. You send it to 8 people and all those people retweet it to their 10 people, to their 10 people, to their 10 people. And pretty soon you have a viral you have a tweet that went viral or a video that went viral because everybody shared it over and over again, right? So that's the idea behind when something goes viral. It's because the number of people who are seeing it in a very short amount of time. Hence, this is called a geometric or an exponential function, okay? So as soon as this loads, let me get that to sync. Okay, so here it says how many people will receive it on day N. Look, we already answered that question. It's up here. So let me go like this. Let me pull this down here. That's done. Okay, so we are going to, let's see. So now you have this one done and this one done. And then, so the big thing here that we want to talk about. So I'm going to pause and then I'm going to go for ready for more, and then we'll be done.